San Francisco is home to some of the most innovative companies of the 21st century. This pioneering and forward-looking spirit is alive in San Francisco government as well. The new headquarters of the San Francisco Public Utilities Commission at 525 Golden Gate Avenue is more than just a 13-story government office building. Instead, innovative city leaders, departments, and project managers joined forces with local architectural firms KMD and Stevens Associates to build one of the greenest office buildings in America. It's more than a building, it's a living system. When San Francisco first bought this land in 1999, it was home to a state office building.
This was an old 8-story brown building the state owned, and the state workers' comp people were in that building.
It was an old, decrepit building for decades. When I was a member of the Board of Supervisors, all of us wondered, bewildered, why we hadn't done anything there, and then as mayor, felt the same.
An earthquake happened, the building was uninhabitable, it sat there vacant for quite a while.
So the city decided to buy the building in 1999 for $2. We worked and looked at ways that we can utilize the building for an office building. So we decided to build an iconic building that will house a lot of city departments.
The San Francisco Public Utilities Commission has an important job. We provide clean, pristine, and reliable drinking water to 2.6 million people in the San Francisco Bay Area from the Hetch Hetchy Regional Water System. We also generate clean, renewable energy for city services like public buses, hospitals, schools, and much more. And finally, we collect and treat all the city's wastewater and stormwater, making it safe enough to discharge into the San Francisco Bay and Pacific Ocean.
In 2006, the PUC was planning and managing a record number of projects.
You know, the Public Utilities Commission is a very infrastructure-rich organization. We're out there rebuilding the water system. We've been working on power generation upcountry. We've been doing streetlights in the city. We're in the middle of looking at a brand new rebuild of our wastewater systems in San Francisco, and we haven't had a home that's been other than rental during all that time.
With a staff of over 900 people, the PUC was leasing 2 office locations.
And finally someone said, you know, this is such a great place for a building. If the PUC owned that building and we could make that the iconic, sustainable building the PUC represents, wouldn't that be a dramatic idea?
So one of the major decisions we made was we wanted to make a statement with this building. We wanted this building to be a LEED Platinum building, which is very few buildings in San Francisco that achieve this mark.
LEED stands for Leadership in Energy and Environmental Design. It takes a look at the way we think about the places where we live and work. I like to think of it as designing for human and environmental health. LEED addresses 5 categories that enhance the environment: indoor air quality, energy, water, materials and resources, and sustainable sites are the 5 categories for gaining credits under LEED. You can go for silver, gold, or platinum certification.
The city wanted to be silver LEED status. Maybe gold was a stretch. And people said, no, if we're going to be the sustainable organization that the PUC is, this has got to be the top of the line. It's got to be a LEED Platinum building. What does that mean to us? We run water, power, and sewer. So those are some of the biggest things involved in LEED Platinum.
And by mid-2008, the project, as we got the contractor on board and we were able to start pricing it, we were multi-million dollars over budget.
The story a lot of people don't know is after we got selected to do this project, the first price that we came in with was $180 million. And the city said, you know, this is a great building, but we just don't want to spend that much money. So the project was on the verge of being canceled.
If you're looking at why this building came to be, in many ways it also included Mayor Gavin Newsom particularly, who really had an affection for this building. He saw the design, he saw the potential, he wanted to make sure that that building got built. And he said, do what you need to do, but please, if you can make that building work, we need to have that building in Civic Center.
I happened to be at a green conference in Santa Clara with Gavin Newsom. I said, you know, you really shouldn't cancel that project. He said, oh, I know. Could you maybe work with us? And so Michael Cohen, the economic advisor to the mayor's office phoned me up the next day and said, can we cut $40 million out of this project?
If there's one person more responsible than any others, it's Tony Irons. Was the architect that was responsible for the revitalization of City Hall, who came to my office and said, we cannot abandon this. We can't walk away from this project. We have an opportunity to really take a lot of our values and principles, particularly raising the bar as we did as a city on our green building standards, mandating the most aggressive green building standards for private construction anywhere in the United States, and showcasing them in this new building.
For the city and for the SFPUC, it was critical that the building stay as a LEED Platinum building, because the easiest thing to do to cut out millions of dollars would have been to say, well, let's just go from LEED Platinum to LEED Gold. But that wasn't the objective. This needed to be the best example of energy conservation of any office building in the United States.
So Tipping Mar became involved in the San Francisco Public Utilities headquarters project during a time when the project was at a standstill for a number of reasons, largely due to budget issues. And at the time, we were asked to consider an alternative design using concrete rather than the scheme that was essentially planned for previous to that, which was a steel frame structure that used hydraulic dampers to control seismic motion.
So I met with my team, we worked hard, we came up with a great idea. Let's take out the heavy steel structure, let's put in an innovative vertical post-tension concrete structure by Tipping Mar, a great idea. We did that, a lot of other things, and we came up with a price of $140 million. So we achieved that goal.
And so when we first started looking at the building, it was going to cost a lot of money. Because of the way it was being built, we could only get 12 floors. We wanted more space for our employees. We ended up going and saying, okay, if we do a concrete building instead, which was Webcor's idea, we can get 13 floors, not 12 floors, because concrete doesn't require as much space between the floors as the steel building does, and it could be cheaper. It's like, yes, more space, less money, great idea. We know that right now there are things happening in power, with sewer, with water, that are not always proven technologies, but they're things that are well enough proven that you should take a bit of a risk and you should show others it can be done.
Fortunately, the world suddenly had wind turbines, which they didn't have before. And so our team, realizing that time had changed and realizing where the opportunities were today, scratched their heads one day and said, you know, what we started out as really something to control the wind was an asset that when you combine today's technologies, becomes something entirely different.
Wind turbines in an urban environment is a relatively new concept. There are a few buildings in other major cities where they have installed wind turbines on the roof.
And wind turbines on buildings aren't really perfected yet. The discussion was, do we do that or not? And the answer was, of course. If they're not perfect yet, we're building a building that's going to last 100 years, and in 100 years, someone's going to perfect really efficient wind turbines, and if these aren't right, we'll replace them. We have time to do that.
The building has 2 renewable energy generation, and there are wind turbines located on the north facade, and 3 different levels of photovoltaics.
We have over 600 solar panels at 3 platforms on the building and 4 building integrated wind turbines. The wind turbines and the solar panels produce 7% of the building's energy, and we're reducing the use of energy here by 32% over a typical office building.
The entire building is controlled by a complex computer system which monitors and adjusts air, heating, and lights, as well as indoor shades.
The building is going to be a smart building. It's going to have all integrated features. So it has a monitor on the roof that knows where the sun is. As it gets warmer or colder, it heats and cools the building. As it gets lighter, shades can go up or down to make sure that you're not overusing any kind of heat or air conditioning. But as it gets darker, the shades can go back up. The lights inside the building self-adjust depending on how close they are to the light source of outside, how light it is, how dark it is. And so you're not using energy more than you need.
They also have occupancy sensors. If nobody's in that room, lights turn off. So it's one thing to have different silos of sustainable features. It's another thing to have an integrated systems of sustainability.
When you have a building that's LEED Platinum, there's a couple things that is really important, and one is daylight harvesting, where you harvest the daylight and have it penetrate the building so that people have views, they see sunlight, which means that partitions and workstations are much lower so that people can see.
So human comfort combined with light reduction, the amount of electric light reduction, all with the aim of creating a marvelous workplace that people want to come to, feel comfortable working in, thrive at what they're doing, all kind of integrate together, and the daylighting, lighting sort of strategy is a very important part of that equation.
One of the keys to this building is that we're maximizing the use of natural daylight to light the building. Here on our south facade, we have light shelves. These light shelves help to shade the floor, but as well, light bounces off of the light shelf into the interior of the floor, providing more daylight into the interior of the floor. Lighting is both the greatest use of energy consumption in an office building, but it also contributes to the largest amount of heat gain in the building. We're maximizing the use of natural daylighting. We also have light sensors that minimize the use of artificial lighting.
By having exterior Venetian blinds outside of the building's skin, what that does is we are mitigating it before it hits the glass. We have a high performance, low thermal gain glass, and so the HVAC system does not have to work as much to either cool the building or heat the building.
This building also incorporates or utilizes an underfloor system for delivery of heating and cooling to the building. This, in conjunction with the high efficiency equipment that we've installed in the building, reduces the consumption of energy for heating and cooling by 51%.
We have Otis Gen 2 destination elevators here. Destination elevators save about 35 to 40% of the electrical energy over a traditional elevator. These elevators save energy by using a regenerative drive. When the cars are going up empty or down full of people, they generate electricity that goes back into the building grid. These elevators save energy by grouping people going to the same floor in the same cab. And the way they work is you have a shared elevator call button in the lobby. You would indicate which floor you are going to, for instance, like 3, and it will direct me to elevator C. So I'll go to an elevator with people that are going to that same floor. What's also interesting is inside the elevator cab, there are no floor selection buttons because I've selected my floor in the lobby. This takes some getting used to as we're all accustomed to choosing our floor inside the elevator cabs.
Another precedent that we set that was a challenge for this building was the permitting process for the living machine to use reclaimed water in an office building. And I think that we really broke the ground for future use to be much more commonplace for the utilization of reclaimed water in office buildings. This building uses 60% less water than a typical office building, and that's achieved by using rainwater for our landscaping, treating wastewater on site for reuse in the building's toilets.
The living machine is an ecological wastewater treatment system for water reuse. So the living machine, to accelerate what happens naturally in nature, this biomimicry, what happens in tidal estuaries. The tide brings in water and the nutrients to the microbes, the tide goes out, the nutrients are sticking to the slime, the biofilm at the coast, on the rocks, and then oxygen, of course, is delivered in the air, and they do their microbes do the rest of the process, chewing up those nutrients in the water and producing nitrogen and carbon dioxide. So we're mimicking that in an engineered system, whereas we're creating 12 to 16 tides per day.
So the wastewater for our building begins its journey by traveling to our primary tank, which is beneath these fairly normal looking manholes. Now beneath these manholes is a 10,000 gallon primary tank. And within that primary tank, there are 2 chambers. The trash chamber, which filters out all the trash and plastics, and the settling chamber. And in that chamber, the organic solids settle out, just as in normal wastewater treatment processes. The water then flows through an equalization tank, a recirculation tank, and then on to tidal flow wetlands cell 1A. Although these wetland cells look to be only 3 or 4 feet deep, they're actually 8 feet deep below this concrete sidewalk. The water repeatedly cycles into the cell from the bottom up. As the water comes up into this cell, it meets the microbes that have been placed in here to treat the wastewater. These microbes flourish on feeding off the organics that are found in the wastewater. After multiple cycles, most of the wastewater treatment has already occurred, and the water then flows to the vertical polishing wetland cells located around the corner on Polk Street. The final polishing cell 2C is located half outside on Polk Street and half inside in the building lobby. After the final polishing, the water flows to the disinfection room in the basement of the building. There, the water goes through two disinfection processes. First, ultraviolet light, and second, a dosing of chlorine. The treated water is stored in a 5,000-gallon reclaimed water tank, where it is pumped throughout the building for toilet flushing purposes. The treatment cycle is complete, and the water is reused again and again. This new building also features a rainwater harvesting system. Rainwater is captured from the building's roof and the children's play area along the side of the building and sent down to our disinfection room where there is a 25,000-gallon cistern. The rainwater receives minor treatment and then is used to irrigate the building's trees and landscaping.
When we're reusing water that we already have on site, we're not purchasing new water, and we're also not putting sewage down into the sewer system, which costs money. For the PUC project, this is a demonstration project of 5,000 gallons a day, but it's the beginning of understanding and feeling comfortable with this technology that can be scaled up into eco-districts and community scale systems, campus type systems, where in those situations when the water is reused and the numbers are much higher, 50,000, 100,000, 200,000 gallons a day, imagine the savings on that you're not purchasing fresh water and you're not using the sewer and being charged appropriately. This wastewater processing and reuse technology is cutting edge. And although it's been successfully implemented in other cities, it will be one of the first such installations in an urban office building.
Here is a city agency that treats wastewater, but they send no wastewater to the treatment facility. That says a lot.
Instead of 12 gallons per day, occupants are using 5 gallons per day. With the building that's officing 1,000 people, that turns out to save over 2.7 million gallons a year.
The Public Utilities Commission runs your water, power, and sewer services for San Francisco. We can't afford to be out of business after an earthquake. So when we're thinking about building a building, that building is going to hold our operations center and our emergency operations center for things like earthquakes. That building had to be immediately occupiable. Great. But we could do better than that. And so this new technology that we ended up using was a concrete building with straps, basically, that go through the interior of the building that allow the building to turn or twist as part of an earthquake, but it corrects itself.
In the cores for the SFPUC building, we've actually incorporated, in addition to that steel that's embedded in the monolithic concrete, specialized high-strength cables that are not bonded to the surround concrete, but are threaded through essentially hollow conduits in the cast concrete. And when those cables are threaded, they are actually anchored, and there's actively millions of pounds of force essentially pressing down and forcing that concrete wall into a permanent state of compression. And that's the characteristic which allows the building to shake, absorb energy from the earthquake, deform, and also come back to its original geometry. And what that meant was that the building would be functional. It simply meant that it wouldn't have to be abandoned and fixed.
We have probably the greenest specification for concrete ever developed for a project that has a really innovative structural system.
One of the things that's evident from the research that's been done is that concrete is responsible for a significant amount of CO2 production, and that's worldwide. And we developed a way in which we could incorporate replacement materials such as slag and fly ash to supplement the Portland cement and allow a big reduction in those carbon emissions associated with production of Portland cement.
Concrete for the building has a 70% replacement value with recycled materials, fly ash and slag recycled materials that would otherwise go to waste, reducing our carbon footprint in half.
The way that we often do buildings in the city or often projects in the city is we go out and we do a low bid, somebody bids on something, we have to do everything that's spec'd out completely, and then everything else after that's a horrible change order process, and it's very difficult.
Traditionally, we use design, bid, built type of delivery method. In this one, we did a construction manager GC, which really means that we bring the contractor on board as we design and they participate in the design. It brings a lot of collaboration.
The Department of Public Works decided to try a more team-oriented approach with this project, a best value approach. And so they really looked to us to come on board as a team member and work with them.
What that meant was the contractor, along with some key subcontractors such as electrical, mechanical, plumbing systems, would always be reviewed and looked at for constructability, for cost constraints, for scheduling.
And it was a risk for the city. It was a change for the city. It was something very, very different. We met all of our project parameters, the budget, the schedule. We love this project. It is a fantastic example of what can happen when you take a risk, you do something differently, and you work together, you get a great result.
One of the things we're going to have in that building is going to be this media wall in the lobby. And that media wall has several things that it can show people, but one of the things it can show our employees and our visitors is how much energy, how much water, what we're using in the building.
So the right side of the wall is based on building data. We have total energy use per floor. We also have energy use in the building today. It'll show information and percentages on how much is being used today versus an average day. There's also information from solar, how much solar the building is producing and showing the savings from solar. We also have reclaimed water at the SFPUC building, and that will also be shown here per month. The center section is dedicated to water, wastewater, and power. So we have live information showing us how much wastewater has been treated so far from the night before. There's also Twitter feeds and information that anyone that comes in can see, just current news and information from the Twitter. There's also BART information. When's the next BART leaving? When's the next train departing? And there is weather at Hetch Hetchy and also weather at San Francisco.
The digital arts wall is comprised of 54 feet of 160 high-definition monitors that has a 3D motion detection that allows you to approach the wall and then to look at the content that is there in front of you, which is a beautiful artistic narrative. And then as you move towards it, it activates deeper content that comes up.
This is one of the main applications we developed with the communications team at the PUC, and it's called Snowfall to Outfall. And it's about the water cycle, how the water comes down from the snow in the Yosemite, melts into the reservoir, then gets treated, produces power, comes all the way down to the city, and then gets discharged as clean effluent once it leaves the bay. We developed a motion tracking system with 4 cameras on the ceilings here, which detects people when they approach the wall and presents information pop-ups. So you can enjoy it from a distance as a landscape, but then once you get up close, there's another level of information that's educational about the system.
Firefly by Sebastopol artist Ned Kahn is an art installation which rises straight from the Golden Gate Avenue sidewalk to the top of the building.
The Firefly wall will be 5x5 polycarbon plates that will move with the wind and show like a wave effect in the daytime. When those also swing back and forth, when they hit the fulcrum, they will also set off an LED light that will be the color of a firefly. So at nighttime, people in the northern part of San Francisco can see the side of our building, and about 20 feet wide and 10 stories high will be a wall that will flicker on and off like fireflies at nighttime. It will be so energy efficient that if all those lights were on, it would be the equivalent of a 40-watt bulb.
And I saw the new piece of artwork going all the way down the side of the building, which looks like this incredible wind ripples on a pond. And I thought, oh my God, how incredible, how wonderful.
Inside the building, we will have water walls in the main staircase, and the water will be dripping through the side of the wall. You'll be able to hear it, you'll be able to see it. We put out a call to San Francisco artists and San Francisco galleries and said, hey, we want a building that is a place people want to come to work in and to visit. We're now going to be buying art from between 80 and 100 local artists in San Francisco, and the Arts Commission will be hanging that art over the next couple of months for the building. We'll have a cafe in the lobby. The cafe will be serving people there. We'll have a child care center on site so people with children can come to work. If something happens to their child, they can walk right downstairs. It has enough space for 65 kids.
We looked at various ways that we could be creative in promoting alternative transportation. We did this by providing bike racks and showers in the building, reducing the number of parking spaces to 2 parking spaces, and providing electrical charging stations for alternative vehicles.
And so it's time for us to have a home, and it's time for you to have a home that all of us can be proud of.
And we couldn't do this without everybody working together on one goal, which is let's build something that reflects the honor of Hetch Hetchy, the honor of the greatest engineering feats, reflects what our PUC does for our public, and for generations to come, it will educate everybody.
I'm really proud that one of the greenest and most sustainable buildings in North America is here right in District 6. The wind turbines, the solar power, the living machines, recycled water that Ed and the mayor has already spoken to. And what's also amazing about this building is that it's not just internally, but you can actually see it on the outside. So when people are walking around the city, they can actually see the green and environmental aspects.
What better way to show that the PUC cares about the environment, and the PUC is going to show everyone else, you can do this too, and you can do it in a way that makes sense, that's affordable, and that is better for the environment.
And this is the most energy efficient government building in the United States today, if not the world. And it is an example that the entire United States can look to and say, that's what we need to do to save our city hundreds of millions of dollars in energy consumption a year, and set an example to everybody of how to save energy, to be green, to be sustainable, to be responsible. The city is leading the way.
It will be immediately recognizable and iconic from various parts of the city, or even when you see a picture of it, you'll say, that's the SFPUC building. My God, isn't that a wonderful building? Didn't they do it right?